the last session of the day, so everybody's just going to try to finish it off and go back home early. So I'll try not to keep you guys waiting. Right, as Doctor introduced, my name is Suresh. I'm currently working for a Tier 1 ISP in Malaysia, Time.net Berhad. We provide bandwidth solutions, dial-up, broadband connections. Something's wrong with my clicker. Let's just see whether this works. All right, now this session is basically to give an introduction of what cryptography is. A lot of times we know applications use cryptography, but a lot of people don't realize what is it about, what are the terms involved in cryptography, how does it work, what does all this jargon mean. So this session is basically to give an introduction of what the technology is about, how does it work, and how you could probably use it in your environment. I'm going to cover about basics. What is cryptography? I'm going to look into how cryptography came into the picture in this world. I'm going to look at what are the algorithms, what are the methods that you can use to encrypt or decrypt your messages, and implementing issues if you are a developer or if you plan to start up a system that uses cryptography, what are the issues you need to look at, and the last part is summary. Okay, something is definitely wrong with the slides. Next one. Okay, now, in security, practically what we talk about is, these are the common points that people look at for security. Number one is secrecy of information. You have some sensitive information, you don't want to tell it to someone else. Like for example, just say if you're married and you have an affair outside, obviously you don't want your wife to know about your affair, right? So, secrecy of information. Authentication of user. Assuming you make a call to the person that you're having an affair with, obviously you want to make sure that that is the person you're calling, right? You don't want to end up calling your wife and calling her another name. You get busted, okay? Integrity of information. If just say, if I were to tell you like A is equals to B, you need to make sure that the information that I give you is accurate, it is correct. Non-repudiation of agreement, okay? I don't want to tell you something so that the next day you come and tell me, oh, I didn't tell you that. That means you deny what I tell you. You want to make sure that the message gets across and the person acknowledges and the person knows that the message is valid. And availability of service, very importantly, right? Okay, what is cryptography? Cryptography is basically the art of keeping secrets. It means, how do you keep a secret? How do you hide it? Like for example, if you go to this shopping malls, you have these diaries with a small padlock and a key, and only those who has the key can open the diary, right? So it's a way of you protecting your private secrets. Okay. Oops. Right, next slide. Okay. Now, the evident use of cryptography was found during World War II, where the Germans started to send messages which the Allies couldn't understand what they were. So they started looking around and they managed to capture something called the Enigma engine, where when you type A, something else comes out. So that was the one of the most primitive form of cryptographic device. What it does is that when you type A, something comes out, you type B, something comes out. So the only other person who could decrypt it is the other person or the recipient of the message who has the similar engine, right? Next, please. This is basically how it looked like, pretty crude keyboard type of environment. Next. Right, now, a lot of people talk about cryptography and security. What is the relationship? Cryptography is just a subset. It is not security itself. It is just one of the means that you use to secure your environment. That's about it, right? Cryptography alone is not enough. There are many ways for you to implement security. You can use cryptography to harden it. That's practically what you could do, right? However, it's not very easy to implement cryptography. It is quite complex. It is actually a very complex mathematical computation. So what happens? If it is complex, it's going to take a little bit of your resources, right? Okay. Now, what is encryption? Everybody keeps talking about encryption the whole session. Encryption is basically a way for you to change your message so that nobody else understands. Like for example, just say if I substitute A with the letter F, B with the letter G, So the other person who gets the message must know how to substitute it back. So the process of changing your message from a readable form to an unreadable form is called encryption. Next, please. Okay. Now, the other person has got your letter, but the person needs to know how to map it back. Like for example, F back to A, G back to B. So the process of making that non-readable message back to your readable message is called decryption. So it's actually a two-way process. You encrypt the message, send it to your recipient gets it, decrypts the message, and reads the message. Right? So we're going to look at some of the algorithms that are available, what you can do with encryption. Next. Okay, cipher. Cipher is basically the algorithm or the method that you use to encrypt your messages. Like for example, just say if I substitute A with F, B with G, that is a cipher. So you must know what kind of algorithm you use. Right? Just say if you receive a message, if you don't know what kind of algorithm is used, you cannot decipher the message. So you need to know what is the cipher. Only then you can read the message. Next, please. The key. Now, the key is basically how you use the cipher to create that mangled information. Like for example, if you see A to F, I think there's about 10 characters, right? So you take A, you add another 10 more characters, you get F. You take B, you add 10 more characters, you get G, for example, right? So there's actually a key there that tells you how you can get it done. Right? So that is just a method of you to use the cipher to get to the unreadable format. Next. Key space. Now, for a person who's slightly smarter, if I use one key, somehow or other, somebody is going to end up guessing it and say that, okay, fine, this person, I think this message looks like it has a certain format. So they probably take a while, think about it, and they find out, this message is using this kind of key and probably this algorithm. Now, if you want to have multiple keys, that's when you use something called a key space. A key space is where you have all your multiple keys. Alright, plain text is what your message is. It is in the plain readable format, anybody can read it. Right? Next, please. Ciphertext. Plain text, encrypt, becomes your ciphertext. Ciphertext, decrypt, becomes your plain text. So the whole process is encryption. If you want to change it to an unreadable format or to a ciphertext, it's called encryption. From your ciphertext, you change it back to your readable format, it's called decryption. Right. Now we're going to look at three main types of algorithms that are used till today. Okay. These three algorithms has its own use. You can use it in your own environment. Most of the libraries have implemented some of the encryption algorithms. I'm going to give you some examples so that you can go back and have a look at it. Next, please. All right. This is basically the process of using a symmetric algorithm. Symmetric meaning one way. Okay, if you look at the algorithm, you take your message, just say your letter, you have your encryption algorithm, and you have your key. You have this one key here. It's like your, let me see if I can get my key. It's like your car key. Everybody has one key. In order for you to open your car, you need your key. Right? There's only one key. Now, assuming one of you managed to get my car key and you know what's the car number, you can just go to my car, turn it on, and take it back home. Right? So it relies on this one single key for you to be able to access to that information. So what happens is that you take your message, you have your encryption algorithm, put in the key, you get your ciphertext or your encrypted message. So now what happens to the other end? Once the person gets it, he needs to know the key or he needs to have the key. So he puts in the key, decrypts it, gets back the message. Now, if you look at it, everything here depends on the key. They call it a shared key or a shared secret. Now, a secret is never shared, right? If you share it, then it's no longer a secret. So what happens? As you can see, the weakness here is that one key over there. So the person who gets the key gets to decrypt your message. Provided you know what is the encryption algorithm. Okay? Encryption, most of the encryption algorithms are two ways. You use the same algorithms to encrypt, you use the same algorithms to decrypt. So there are two things you need to know. Just say if you want to be a successful decryptor, for example, what you need to do is you must know what algorithm they use, you must know what is the key. Now, one example of not to do, you send a zip file and you send a password. Most viruses do this, if you realize. This is the zip file, open this is the password. Now, that defeats the purpose. Assuming I'm a hacker in the network, I put a sniffer inside that. You send that message together with the password. I manage to sniff the whole message. I get the just a zip file together with the password. Don't you think I'm able to open it? Right? So that is one of the things not to do. Yes, you did the right thing, you encrypted the message, you have the key. But the mistake was that you sent the key together with what you encrypted. So the attacker who manages to get the message gets the key, decrypts whatever you have. So one example of things not to do. Next please. Alright? So as you can see, it uses a single key and it relies heavily on that one key. Like how you open your house door or your car door, right? So some of the example of one-way encryption is RC4. RC4 is widely used in WEP, Wireless Encryption Protocol. Do you know where is WEP used? Anybody? Nobody? Wireless. That's why it says Wireless Encryption Protocol, right? So this is actually a symmetric key. What happens is that when you want to connect to a network that is WEP, what you need to do is you must have the key. They call it the pre-shared key. So what happens, all your messages get encrypted with this pre-shared key, sent to the AP or the access point. Access point decrypts it, sends it as a normal plain text packet through the wire. That's what it does. The security of WEP is from your machine right up to the access point. Beyond that, it is plain, right? Anybody can tap onto it. Next, please. All right. Now, they found out that this is not really an effective way to do things. The last thing I want to do is send a password and say, hey, use it and open it. Somebody gets that key, everything is lost, right? So what they've decided is, why don't we do something slightly more complex by using asymmetric algorithm? Now, let's look at a simple example. Just say I want my friend Ali to send me something, okay? So what I do, instead of sending him something very expensive, I send him a nice big lock. I send him a lock. I don't give him the key. I just send him the lock. I said, Ali, put all your stuff in the trunk, lock it with the lock I give you, you send it to me. Now, he's going to lock it, he's going to send it to me. He can't open it after he locked it. That's it. Once it's locked, it's done. He sends it to me, I have the key. I open it. This is what you call the public key infrastructure. The lock that is sent there is the public key, is the lock. The iron key that I have here is the private key. So what happens is that you can send the lock to as many people as you want. Alright? The person only has the lock, he doesn't have the key. So he's going to lock that information, send it to me. Since I have the private key, only I can open the trunk. So this way, it's okay for you to send the public key out. There's no problem, because it's just a lock. Right? What are the ways of using public key infrastructure or asymmetric algorithms? You can use PGP. Right? How PGP works? When you create a keypad, they call it a keypad, a public key and a private key, you will store your public key in a directory services or a directory server, like your openpgp.net or whatever. Alright? Just say if I want to send a message to you, I'm using PGP. What I will do is I will check with the public directory services to see whether you have a public key. If you have a public key, I will download that public key, which is the lock the message, email it over. Since only you have the private key, you can open it. If he sends it to me, he's going to search for my public key. So the only thing that goes across the network are your public keys. The private key stays private with you. So it is very important when you have digital certificates or when you have these kind of facilities, make sure you keep your private key safely. Anyone who has access to your private key will be able to open and decrypt your messages. The person can also sign the message saying you are the person. That's called digital signing, to verify that you are the founder. Yes? Okay, now, let me finish this. When I come to digital certificates, I'll explain to you that. Right? Okay, next please. This is how it goes about, right? You have your plain text message, you have your encryption algorithm where you send in your public key. Sorry, plain text. Okay, I got the keys mixed up. The public key should be on top, the private key should be at the bottom, alright? I send you the public key, you use that, which is your padlock, encrypt the message, send it over. When I get it, I use the decryption algorithm with my private key, decrypt it. Okay? Pretty simple process. Now, to answer his question, in an environment where you use PKI, public PKI, where you have certificate authorities, all right, where you have root CA, offline root CA, online root CA. Now, the people who issue digital certificates are called certificate authorities. Certificates are basically a key pair, private key, public key. These are digital certificates. Now, do you know that most of your smart cards, do you know what's actually stored inside those smart cards? The things that are stored inside the smart cards are actually digital certificates. It has two keys, your private key and your public key. All right? Now, I am the certificate authority who issues certificate to you, right? If I can get access to the certificate authority, which in this case is the locksmith, I can open any keys. So in very large organizations, one of the most well-kept secret is the private key of the root certificate. Okay? So if I'm an attacker and I see a PKI environment, the first thing I'll try to do is to get to the root CA. If I get to the root CA, I can basically say I am you and send a message on your behalf. And anybody else who gets it in that environment will actually validate against the certificate authority and say, yes, true, this is this person. Because the digital certificate was issued by the CA, the certificate authority. Okay? Now, in most environments, like for example, just say if you go to a site, you happen to see a small lock down there, right? Just say like if you go to Hotmail or Gmail, okay? Those are certificates that are issued for SSL. Now, most of the time, you will not get a warning box telling you that, do you want to verify the certificate is true or not? The reason why you don't get that box is because the root CA's public key is already in your certificate store in your machine. If you do Windows update for Windows 2000, you would see that one of the options is update root CA, update root certificates. That's because all the main certificate authorities in the world will give their public keys or their public certificate to Microsoft or to any other vendors to install it in their machine. That's why you don't get that warning. Now, if you want to deploy certificate authorities, your own certificate authority, and you don't want that warning box to come out, very easy. Install the CA certificate in your machine. That way you can actually verify that this certificate is issued by a particular CA or a particular certificate authority. Alright? I'm not going to take so much of time to go in. Yes? No. Unless if you're the key recovery agent for the certificate authority who has access at the CA, then you can. But using the public key, you can't. Mm-hmm. Yes. No, you still need the private key of the CA. You see, what happens is that when the CA issues a digital certificate, you're actually going to encrypt a certain part of it with the CA's private key, which means one of the key that you need in order to read, to decrypt the digital certificate that you get is the CA's private key. So it's like your symmetric algorithm. The key here is the root CA's private key. So without that, you can't actually see the details. Okay. Okay, even if that is the case, it's going to take you a very long time. Because number one, the certificate is also generated based on a password. So the password plus a few more processors. If you need more information, you can refer to the X.509 standard. That is the standard that defines how digital certificates are issued. Right? I don't have much of the details here right now. I can take it up with you offline. Let me just get on with the presentation. Next, please. All right, hash algorithms. Now, some of the things that you might find being practically used almost anywhere is a hash. A hash is like a fingerprint. You put a fingerprint that uniquely identifies you. Now, some of the requirements for a hash algorithm is that you don't have any collision. That means, just say if I take this algorithm, I hash it, gives me a value. Okay. One of the most practical uses for hash algorithms is like, just say if you go and download a file, normally they say MD5, this is the string, right? So it actually helps you to verify that the contents of that binary is not changed. So that sometimes, when you download a file, you might miss a bit or you might miss a packet. So the size may look the same, but actually the contents has changed. So one of the ways for you to verify is to run a hash algorithm against that file, get the value, compare it to the original value that it's supposed to be. Like the value is the same, then it's okay. Even if you change one bit in that file, the hash value will change. All right. Some of the practical uses of hash is that people don't store password just like that. They don't store in database. Hopefully not anymore. I know those days they used to just store it as a plain text. Nowadays what they do is they hash the password and they store it as a hash. So what happens is when you try to log into the system, you put in your password, the system will generate the hash of the password you put in, compare it against the hash that you have in the database. If the hash is the same, yes, you're authenticated. So these are some of the practical values of using hash. Now, the thing is, hash is a one-way algorithm. That means you can only hash. You cannot take the hash and reverse it. It is a non-reversible algorithm. You cannot reverse it. So that is why people like to use it for password storage. But the problem is this. You can use a brute force attack. That means you start A B, A C, and somehow or other try to find out what is the value used on that. But that's going to take you quite some time, right? Some of the most common hash algorithms is MD5 and SHA-1, all right? I think recently I saw one article about MD5 actually repeating the hash by itself. I don't have the URL with me right now, but if any of you are interested, you can come and see me after this. Pass me the email address. I could send you that article. Right, next, please. Okay, now, what is the practical use of cryptography? One of the most common ones with organizations use are ASMIME. That means encrypted emails. Okay, there are two parts to it. Number one is encrypting that message, sending it to you. That's one thing. The other thing is for large organizations that have your public key infrastructure in place, they use the public key and the private key to actually sign the message. So when you sign the message goes to the other person. The person checks the value of that signing against the CA. CA will then say, yes, this is the correct message. The message has not been tampered. Sometimes you can actually see PGP signing. You want to sign a message, you can actually sign a message. The reason why you want to sign it is to verify that you are the person who's sending that message out. Alright, if just say somebody's not sure whether it's you or maybe your kid brother behind your Outlook Express sending an email out, right? So for you to verify it's you, you can use that, right? Application layer protection. Like for example, you want to make sure that some of your sensitive information are kept secret. Nobody can just open a text file and see what is it inside. So if you have a lot of text files, you should keep it in a format where nobody can read it. And if you want to read it, you can decrypt it and get back the original value that you want. Okay, network layer protection, like your VPN connections. Most of the most common VPN connections are the IPsec-based connection, whereby you encrypt the payload of your TCP packet and send it over. And the other side will actually verify to see whether there are any tampering done in the packet or not. If it is, it's discarded and you get to send it back. So these are some of the common usage of cryptography. Next, please. Okay. Now, what are the issues you might get if you want to implement cryptography? Now, as you know that cryptography is a very complex mathematical calculation, right? So in order for you to calculate all this, you may need to take CPU resources. You may need to take some memory resources. So, like for example, just say if I use an IPsec VPN, the more users I get connected to my VPN box, obviously you might gonna see it getting slower and slower and slower, because the reason being is every single connection it establishes, it needs to encrypt, right? However, with the current advances of technology, you have all these triple dash offload cards or encryption offload cards. So what it does is it actually stores the algorithm inside these cards. These cards will actually do the computation for you. So you free up the CPU resources. Instead of relying just on your CPU resources, you do the computation on the card and you send it off. In fact, some of the network interface cards for servers comes with built-in processing power for your triple dash or your VPN connection. So if you're looking at deploying encryption, you might want to look at some of these factors also. Next, please. All right. I've basically come up to the end of my presentation. This presentation was basically aimed to give you an introduction or a good feel of what is encryption, how does it work. Like for example, you might have been using PGP, so hopefully I've given you some basic information that you can take back, and probably when you have all these issues or you have any implementation that you want to do, you can take some of this information back and put it as a consideration if you were to deploy an algorithm. Now, some of the things that I did not put into the slides are that look into the algorithm that you plan to deploy. Some of the algorithms have been broken before. Try to avoid that. Okay? Some of the strong algorithms are like AES 256, AES 512. Triple dash is still okay, but I think there are much more better algorithms or faster algorithms than triple dash. Right? These are some of the things you should look at. Just go around Google on the net. You should be able to get loads of information on encryption. In fact, there are a lot of libraries that are out there that gives you a very easy way of implementing encryption for your applications. Right? So one of the things you can do at home is start encrypting your mails. You won't know who on the ISPN, devils like me, sitting down, got nothing to do, just pick up 1, 2 mails, sit down and read, see which love affair is going around. So if you don't want that to happen, start encrypting your mails. But in order for PGP to work, both sides must have that application. You can't just send an encrypted message to the other person, and if the person don't have that program, chances are your message will just end up in the trash can. Right? So if there's any questions, I'll be more than happy to take it. Yes? Um, okay, the question is, what are the kind of attacks that can be done to PGP deployment other than man-in-the-middle attacks? Most probably social engineering. Now let me just explain what social engineering means. I go up to his house, buy him a cup of tea, and I put him to sleep, go to his computer, steal his private key, and whack that thing off. In fact, you'll be surprised that most of the organizations, I can't show you my ID, then I know you guys are going to do it to time. All you need to do is just take a photograph, put it on a badge, and you can go right up to the IT department and just say you're going to deliver something, go into the server room, plant the Trojan horse, come back home. It's actually very easy than sitting down behind a terminal, punching away 33,000 different types of passwords just to break into SSH. I think that's much more practical. Right? That's one way. Other ways, look at vulnerabilities that are related to PGP. I think PGP 7 and 8 had a few vulnerabilities. I think you could use that to exploit. Other than that, PGP is just another application. If it has a vulnerability, you have to patch it. You have to upgrade it. Right? Standard practices of what you need to do. Any other questions? Yes? Brute force. Can brute force be used? Yes, it can. Yes, it can. The quality of the public key and the private key that is created fairly depends on the password. It really depends on the password. Okay, the public key actually gives you a hint of how the mechanism is. I have yet to see anything or any tools that basically takes the public key and gives you the private key. I have yet to personally see that. So maybe up to today I could say that the PKI environment is still a bit secure. I'm not going to say it is the secure, I'm going to say it's a bit secure. right? Probably until the day where somebody finds out that you can break the X509 and get a private key based on the public key, then I think probably there's going to be a different kind of algorithm that comes out.
No, if they can do that, your whole public-private key breaks down.
Yes.
The private key is the one-way key.
Yes. Currently, the only way for you to break that is on a CA-based environment. Get the root CA certificate. You get the root CA certificate, you get everything. You can set up a server thinking that you belong to that organization. Alright? The reason why you pay so much of money to people like VeriSign and Thought just for an SSL certificate is because of that insurance that they have, saying that if you buy a certificate with them, that certificate will be tamper proof. Nobody else will be able to issue that certificate other than them. That's all. That's why it still stands until today. If somebody breaks that PKI chain, that means you have to rewrite a whole load of application, right? From SSL, SSH. It's really huge. So if you're really a good mathematician and you have a lot of time to spare, you might want to try that. Any last questions? Okay, if you guys need to get in touch with me, I'll just put up my email address up there. That's my email address, so if you have any questions, you can shoot it up there. I'll try my best to get it answered as soon as possible. Right? Thank you for attending this session. Thank you for your time.